Good day everyone. Welcome to Soil and Water Conservation course. In this session, we'll be discussing the soil erosion process. So here's the outline of our topic. First, we will be discussing the process and mechanics of soil erosion, the two general types of erosion, the factors affecting soil erosion, the factors promoting soil erosion in the Philippines, the categories or kinds of erosion, and lastly, the damages associated with soil erosion. Soil erosion by water has long been recognized as the major cause of land degradation. So this is particularly true in the Philippines, where soil erosion process is exacerbated by the interplay between the erosion-enhancing land uses, erosive rainfall, and sloping agricultural lands. So these factors worsen the erosion here in the Philippines. So unless appropriate farming systems are evolved and adapted by farmers on the hilly lands, these ecologically fragile areas will become some of the most unproductive zones in the country. So kung ma-introduce sa ato mga farmers ang proper or appropriate farming systems, makaproduce na og daghan sa area, then makatabang pa sa atohang environment. So the process and mechanics of soil erosion. Soil erosion is a removal of soil from field by the agents such as wind, water, and or gravity. So the detachment and subsequent transport of soil materials, including rock fragments, by an agent of water, wind, or gravity to an area of deposition. So we have here an illustration on how it works. So tungod sa rainfall, so naay splash nga mahitabo sa soil surface, then ma-detach ang mga soil particles. So hangtod sa matransport siya paingon sa ubos by the action of water, wind, or gravity, so mo transport siya padung dito sa another spot or dito sa area of deposition. Sometimes mabutang siya sa mga lakes, sa rivers, so yun ana. It is very harmful sa atohang environment because kanang mga sediments nga mabutang dito sa lakes is makapollute siya. Then maka-cause nga mamatay ang atohang mga water species. So dako kayo siya impact sa atong environment ug sa ato apod nga human beings. It is a progressive action which starts as inconspicuous little thing and grows rapidly. Erosion started when man first began to clear the land and planted crops for his needs. Cultivation has cleared and often left the soil bare and exposed to wind and rain. So because of us, kay tungod kay kailangan man natong mag-cultivate para makaproduce ta og products, kita ra gihapon ang hinungdan nganong naay erosion. Kay ato mang pangbungkalon, mabiyaan nato nga abli na ang surface nga pwede na siya pwede siya ma-erode due to wind, rain, or gravity. So yun na siya. Tungod kay tara pod ang mga farmers ang nagahatag og way nga magka-erosion sa area. Labi na og wala ta kabalo unsay appropriate nga farming system nga i-apply diraa. The genesis of soil erosion lies in irrational land uses and faulty management practices such as destruction of natural vegetation by overlogging, overgrazing, upland cultivation on unstable slope, practices of shifting cultivation, overall mismanagement of land above its carrying capacity and capability according to Gupta in 1981. So tungod ra gihapon na sa atohang pag-mismanage sa area mo nang nagka-prone ta sa soil erosion. Kay tungod kay gidaghanan nato og butang og animals kato nga area kay para dito sila mangaon, miski ang area is good for 50 carabaos, gibutangan nato siya og 100 ka carabao. So maupaw gid ang area kay nasubraan naman sa animal. So mo na ginatawag og overgrazing. Then upland cultivation on unstable steep slopes bisag ang area is lisod na kaayo siya tamnan kay tungod kay bakilid na kaayo, halam i-cultivate gihapon sa farmers kay para makaproduce, which is makadaot siya sa atohang environment. Practices of shifting cultivation, miski magtanom ta, kana nga area, then kung makuan na ang area kanang ma-exhausted na, so ato na po siyang alisdan og tanom ana, then mo na siya makakuan gyapon siya, cause siya og erosion. Overall mismanagement of land above its carrying capacity and capability. The soil erosion is the detachment and transportation of soil materials from one place to another through the action of wind and water in motion or by locating action of raindrops. So mo na siya according to Waklo in 1981 and Finkel in 1986. So according naman kay DENR, in 1963, there were two kinds. So natay normal or geologic and accelerated erosion. So normal or geologic, it is unaffected by human activities. So kani accelerated erosion, so maning mga erosion nga naay gibuhat ang tao. Soil erosion occurs when water runs over the surface of a sloping land. This water running over the surface is called runoff. The rate of soil erosion will depend upon the speed of surface runoff. Brooks et al. In 1991 described that the volume of runoff as well as its speed depend upon the soil, the slope, vegetation, land use, and intensity of rainfall in the area. So mao na siya ang 5 ka factors kung unsa kakusog or kahinay ang runoff nga mahitabo sa area. Soil erosion affects the productivity of upland watershed and can adversely impact downstream areas. According to De Vera and Rothart Kolpaibon in 1981, every unit of area of land use on the surface of the earth is subject to irrational processes brought about by various factors of erosion such as soil, slope, vegetation, intensity of rainfall, and human. So almost the same lang gihapon sila sa ilang mga nanggawas nga studies kung unsa gyud ang kung asa gyud nagagikan ang soil erosion. Morgan in 1986 stated that the soil erosion is a two-phase process consisting of detachment of individual particles from the soil mass and their transport by erosive agents such as running water and wind. When sufficient energy is no longer available to transport the particles, so a third phase is deposition. So moto ako ang illustration gaina nga natay detachment of soil particles, i-transport niya into padong sa ubos hangtod sa maabot siya sa new spot dito sa area of deposition. So rain or splash is the most important detaching agent. So diha ginagagikan tungod gina siya sa impact sa rainfall, labi na dito sa bare space nga soil surface. As a result of raindrops striking a bare soil surface, soil particles may be thrown through the air over distances of several centimeters. So mo na siya according ni David in 1985 as cited by Ozair in 1994. They stated that the process of soil erosion by water consists of 4 interactive erosion sub-processes, namely detachment by rainfall, transport by rainfall, detachment by runoff, and transport by runoff. So mo na siya ang 4 ka factors. Therefore, soil erosion over a land surface is the product of raindrop impact and overland flow. So tungod lang gid daw na siya sa raindrop impact and sa overland flow katong mag-runoff. Mechanics of soil erosion process. So soil detachment by rainfall, entrainment or transport of sediments, and sediment deposition. So muna to akong gi-explain kagaina. There are 3 processes involved during soil erosion by water. This namely the soil detachment by rainfall. So this is a process by which raindrops splash soil sediments from the soil surface into the runoff. So this can be attributed to 2 factors, the raindrops, and surface or overland flow. Detachment of the soil mass requires energy which is supplied by kinetic energy of raindrops. So, musulod na dahil diri ang physics. So, table 1. The kinetic energy of rain and runoff. So, kinetic energy, yung formula, is 1/2 times mass times velocity squared. So, in mass, so sa rain o runoff ta, in mass, i-assume nato nga the falling rain is R. So, iyang symbol is R. Then, sa runoff, assume that 25% runoff, mass of runoff is equals to R over 4. Kaya in 100%, i-divide na to by 4 is 25% man. So, manang R over 4. In velocity, assume terminal velocity of 8 meter per second. So, in assume speed of surface flow of 1 meter per second. So, mana sa runoff. And kinetic energy, 1/2 times R, or sa rain, yung mass, times velocity nga 8 squared, it is equals to 32R. In runoff, 1/2 times R over 4 times 1 nga yung velocity squared is equals to R over 8. Entrainment or transportation of sediments from upslope to downhill direction, whether in rills, between rills, and in sheet flow. This can be due to raindrop, surface runoff, wind, mechanical force, and gravity. So, mato siya ma-transport ang sediments because of these factors. Ang raindrops, surface runoff, wind, mechanical force, and or gravity. Sediment deposition. So, this refers to the process of sediment settling out under the action of gravity. The rate depends on particle size, being rapid for sand and slow for clay particles. So, kung sandy soil siya, taas ang iyahang sediment nga ma-erode. Unlike sa mga clayey soil, nga hinay ra ang iyahang erosion. So, deposition is a selective process. Next is the two general types of soil erosion. So, we have the geological or natural erosion and the accelerated erosion. So, mato kung gingon kagaina nga ang geological or natural erosion, it is soil erosion that is unaffected by human activities. Ang accelerated erosion, it is affected by human activities. Geological or natural erosion. According to research, a soil loss is about 1 mm per year, and it is fairly matched to the soil formation, which is estimated to be approximately 1 mm per year. Geologic erosion is a slow process, so mas okay na ni siya kaysa sa accelerated erosion. So this refers to the water or wind erosion at more rapid rate than normal, usually associated with human activities like shifting cultivation, overgrazing, deforestation, and etc. So, 10 mm per year, which is about 100 mj per hectare per year at a bulk density of 1 mj over m cube. So, we have here the factors affecting soil erosion. So, we have rainfall, soil erodibility, vegetation or plant cover, relief or slope, and human activities. Rainfall. So, this is a climatic element that is mainly affects soil erosion. So, tungod sa iyang splash, ang soil element is ma-detach dito sa iyahang surface o sa iyahang area. So, the potential ability of the rain to cause erosion is called erosivity. Soil erodibility. This refers to the vulnerability or proneness of the soil to erosion. Some soil properties affecting soil erodibility are as follows: the soil's texture and the soil structure. So, soil texture, this is defined as the fineness or coarseness of the soil particles. Soil structure, it is an arrangement of primary particles into an aggregates that affects soil erosion, directly or indirectly. Directly when they the infiltration increases, and indirectly when the OM or the organic matter concentration increases.